Hello, everyone. Thank you for joining us today. My name is Irina Stoican. I am marketing manager for Fineamin. For the ones who don't know too much about us, we are a Swiss company manufacturing water treatment chemicals, mostly based on film forming amines. Today, we will be discussing about film forming amines, focusing on boilers. My colleague, Mr. Mustafa Kokan, our sales manager, will be presenting this subject. Mustafa?
Yes. So first of all, thank you very much for your participation into this meeting. And this is the second webinar series for us. And we would like to, as Irina said, focusing mainly for boiler treatment. And just let me start by showing you the so I think it is all clear, right? So we will be talking about more giving a focus to boiler treatments and just to say something about our company, as Irina mentioned, and for those of you who participated into our first webinar, basically there will be some slides that look similar as we try to compare the standard treatment and the film-forming amine-based treatment last time. And once again, when I'm pronouncing it film-forming amine, some people say film-forming amine. We also say polyamine, or we also say FFA. Basically, we are all meaning the same. So we are a Swiss company making the production in Geneva, and we have offices in different locations, like in Germany, in Turkey, in Singapore, in Mexico, and in Brazil. And our products are produced principally in Switzerland, but we have also local production in Turkey for Turkish market. And this is basically a journey of more than 50 years about the film-forming amine-based treatment chemicals supplied by Fineamin philosophy. And as we will be taking into consideration certifications too, as you see, that through the webinar, you'll see once again, we are certified by NSF, and also we have ISO 9001 and 14001. So let's start once again the basic understanding of film-forming amine technology. We are talking about formation of monomolecular film on the metal surface with hydrophobic nature. So the hydrophobicity generated on the metal film, precisely on the metal oxide that is absorbed on the metal oxide, will repel anything hydrophilic like dissolved gas and dissolved solids. So this will be acting like a continuous barrier between water and metal. In fact, although we are showing it and there is a much more popularity about film-forming amine treatment nowadays, but the history of the film-forming amine substances dated back 1970s. So for those of you who are interested in terms of the molecular structure, as you see, this is really, really a bulky molecule and with different alkyl chains, R1 and R2. And in fact, that integer, the intermediate group, will also define something. For example, if the N is 0 and the first alkyl group is C13 hydrogen 38, we are talking about octadiecylamine, ODA, one of the first known film-forming amine in the history, I would say. And definitely there are more than one film-forming amines and substances. And we are also using basically another one, ODA, in our formulations. So the idea is always seeing from a different perspective, like first of all, absorption on the metal surface, the absorption followed by the interaction between hydrophilic heads that is ionic, and then there will be van der Waals forces between the tails, and this will be generating hydrophobicity. And of course, that film form will not be affecting basically thermal exchange. So there is no contribution or energy loss because of that. So in the boiler applications, we are using quite a different and very wide range of, let's say, places. So it's in terms of the type of boilers, in water tube boilers, in recovery boilers, fire tube, and as well as in different industries, whether they are heavy industry, power plants, refineries, fertilizer, middle market, basically production, construction, textile, automotive, food and beverage, as well as commercial institution, so hotels, hospitals, airports, etc. So it is really wide applications. And when we are focusing in the applications for boilers, as you may know, we are targeting the treatment in order to overcome problems associated with scaling, corrosion, and carryover. So these are the three technical scopes. So what normally in traditional treatment people are using, they are using oxygen scavengers of different type, dispersants, phosphate, ammonia, or neutralizing amines mixtures. And of course, the treatment is being selected with respect to system data, the boiler pressure, etc. So with respect to that traditional treatment, when we switch into the film-forming amine-based treatment, we are using basically the mixtures, all organic 1 gram solutions. We have mixtures, all organic 2 gram solutions that is composed of different actives. So the core is film-forming amine, known as also polyamine, but of course, the formulations contains also pH-boosting agents like neutralizing amines, and up to certain pressures, also polymers. So, as we said also during our first webinar for the boiler treatment case about the oxygen corrosion issue, so we are mostly dependent in case there is a aerator on the external method, means mechanical removal of the dissolved oxygen. So at the same time, it is possible that we have an economizer in case the condensate return rate is low, and or for the process usage of the steam, I would say, and maybe the steam is becoming dirty after the return. So then the people, they are just throwing away and using an economizer to heat boiler feed water. So these two methods are helping a lot. Why? Because the solubility of the gases, including definitely dissolved oxygen, is inversely proportional with the temperature. So higher the temperature, we remove more oxygen. But in case that in case of some, let's say, low pressure boiler industries, then there is no deaerator, so which means that there is no possibility to remove the oxygen mechanically, and instead we are solely dependent on the chemical. Now, in order to get the real performance and benefit from the chemical, we need to be knowing exactly the boiler feed water temperature. Why? Because the boiler feed water temperature is directly giving us about the dissolved oxygen concentration. So if we are not taking it precisely, we will not be able to read any oxygen scavenger residual. And speaking which of the oxygen scavengers, definitely we have different ones. And for low pressure cases up to 40 bar, the most preferred one is sulfite. And when we go to higher pressures and higher water qualities like demineralized waters, so on and so forth, and then there are other choices like DHA, like carbohydrazide, anhydrazine, etc. Now, one of the most known and used one is for the low pressure is sulfide. So we should also put some focus on sulfide. So it is basically an inorganic substance, and it will also contribute into TDS, which means that it will also limit the operation for the blowdown, because as much as the dissolved oxygen concentration is higher, then we are supposed to use more sulfite. And then technically, although we accept to use it, then we'll be increasing the total dissolved solids or conductivity. Hence, we need to increase the level of blowdown. So this is always back and forth evaluation, and it will give us a pain because at the end of the day, if we are unable to remove oxygen properly, we will have oxygen-related corrosion, not only in boiler feed water lines or in boiler, but also oxygen is a gas. It will go also to the steam, and it will be generating pitting also in steam and condensate lines. So why we are talking about this? Because in Fineamin products, we don't use any amine sulfide or oxygen scavenger principally. So then if the temperature is low or is high, we will not be changing the dosage of our chemical. So the most preferred internal treatment chemical is phosphate and polymer mixtures. So again, in let's say low pressure cases, most people are using inorganic type of phosphates. And because calcium phosphate is much less soluble than calcium carbonate, so in case of any hardness slippage to the system, so we'll be converting into calcium phosphate form that is soft and removable even by jet water cleaning. However, for an extended precipitation of calcium phosphate over the metal surface, and especially when we are also having relatively higher pressures, then we'll be generating basically problems about the heat exchange. So this will be generating steam blanketing and overheating of the tubes and then tube ruptures. So at the end of the day, phosphate is not as innocent as it is thought to be. And when we are going to high pressure applications, in fact, the phosphate treatment is a bit more complex. So we are not using trisodium phosphate or anything like this, but rather we will be using a program called coordinated phosphate treatment program. So basically two-type phosphate in correlation with the pH. But what happens? So it is precisely that in case of change in load during startup conditions or because of the process demand, and then if we have some refurbishment of the boilers, of the burners, the fuel change, fuel to oxygen ratio change, etc., we may face a problem that is called phosphate hideout. Means we are dosing the phosphate, but we are not measuring the level that we dose. So this is the hideout conditions because phosphate is precipitated. But because there is an equilibrium reaction between phosphate and the pH at that instant, while the phosphate is not measured to the level that we dose, the pH is measured more than we dose. So when the return conditions happens, that means the system is stabilized again, then we start to read more phosphate than we dose because we are resolubilizing the phosphate precipitated on the metal surfaces. But because there's an equilibrium reaction between pH and phosphate, then pH starts to drop. So this problem is really, really a very serious problem, and it is difficult to cope with. And again, film-forming amine-based treatments of Fineamin, they do not contain phosphate. So there is no possibility to have phosphate-related issues, including phosphate hideout. So speaking which the high-pressure cases, again, we are talking about the oxygen scavenger issues. So historically, everyone knows, and it is one of the best technically, I would say, oxygen scavenger. People are using hydrazine. So from the technical perspective, hydrazine also decomposes to ammonia. And similarly, people said that, well, we have also the health and issue because hydrazine is known to be carcinogenic. So which means that we can switch into a much more innocent molecule introduced into the market probably like 20, 25 years ago. So it is carbohydrazide. But again, carbohydrazide basically has two issues. Number one, as a part of decomposition, it will be also decomposing into ammonia. So if we have copper and copper alloys in the system, like the hydrazine case, it will be generating issues for the corrosion to yellow metals. Not about this only. Carbohydrazide itself is the molecule as a passivator to work as an oxygen scavenger too. However, between 135 and 200 degrees centigrade, it will decompose to hydrazine. So again, we are talking about the hydrazine formation to the boiler, so it is also exposure to the environment. So basically, carbohydrate has also such outcomes and undesirable points. So the third point, the third problem that we said about the boilers is about carryover. And this carryover is about the steam purity. We may have mechanical carryover that is not depending on, let's say, treat chemical operation. It is mostly about the steam load and steam load changes. However, the second carryover type, that is the chemical carryover known as foaming, is solely depending on the chemical treatment control. And especially in low pressure cases, again, if there is an improper control of the blowdown, high pH, alkalinity build up, high levels of the phosphates and other treatment chemicals, so on and so forth, it may go to foaming, and then this boiler water in forms of small droplets will be transported into the steam lines, but that will impact the steam purity, hence the quality. Again, why we are saying it here, this problem, because in Fineamin treatment chemicals based on film-forming amine technology, there is no possibility to have chemical carryover because our chemical is all organic and contribution to TDS is extremely minimal. So what we have been seeing it as a comparison, just to give also that summary again, basically no sulfides, no phosphates, no inorganic component, and no carcinogenic components. So we can ideally cycle up the boiler to the level we would like to, depending on the limits of operation. We may have lower blowdown amounts, and lower blowdown means lower energy consumption, lower total water consumption, and lower total chemical consumption. So we don't have any carcinogenic, mutagenic components, so we will be fulfilling also health and safety regulations for the workers and for the environment. So this is the comparative, I would say, study that will be showing the positive points of Fineamin film-forming amine treatment. So then another interesting part is about the standby boilers. A customer may have more than one boilers or one boiler with non-continuous operation. And definitely when someone is stopping the boiler and means that it has not been kept under the pressure, but it is fully cooled down. So roughly in a 2 days time, the corrosion will start. Why? Because the dissolved oxygen concentration will increase and it will attack to the metal surface. So then normally people should do the preservation. And again, the preservation is a bit different when it is up to a month, and when it is more than a month, and when it is more than 6 months. So up to 6 months, wet preservation is possible, but up to a month, sulfite-based organic scavenger can be used. But if it is more than 1 month, it is not possible. And because there will be too much sulfite converted into sulfate, that will be generating stress on the metal. And if it is more than 6 months, we go with the dry preservation, like under the inner nitrogen blanket with desiccator inside, so on and so forth. Now, the most interesting part of comparison for wet preservation by film-forming amine treatment of Fineamin is up to 6 days. There is no problem, and we can stop the chemical dosage, and the film formed on the metal surface will stay. So, which means it gives you the advantage if someone has more than one boiler and switching in a course of 6 days from the first boiler to the second, or from third to the fourth, etc. So this will give the advantage not to have any corrosion and not to have any standby measures. And of course, when it is more than 6 days, we have also specific preservation procedures depending on the conditions of standby. However, those conditions and the chemical consumption, it's much more mild than the traditional method using sulfide-based preservation. So that is also another advantage of film-forming amine-based technology of Fineamin. Now, the last part about the boiler treatment is for the boiling out. I will not go into details. This is totally a separate subject. However, when someone compares the film-forming amine treatment capabilities for boiling out, theoretically, we can say that it is possible to use the same treatment chemical to make a boiling out versus different options like using caustic soda, trisodium phosphate, demineralized water, sometimes acid cleaning for some people, and then definitely they have their own cones in terms of the handling, storage, hazardous chemical, dangerous chemicals, possible scaling, etc., etc. So this is also a further application area in boiler treatment of film-forming amine treatment of Fineamin products. Now, at the end of the day, what we are saying, yes, that the treatment as the core philosophy has surface active film-forming amines, polyamines means FFAs. But we are not talking only the product that contains polyamines inside. We are talking about specialty mixtures that also has neutralizing amines and up to certain pressure limits, polymeric dispersants that will really help. And as I said at the beginning of the presentation, basically we don't need to use an oxygen scavenger. However, for certain clients, there is the key performance indicator value as for the dissolved oxygen. So we are protecting the metal surface from the oxygen corrosion by making an hydrophobic film so that will repel dissolved oxygen, like the painting of a metal surface, I would say. But as you may understand, there is no stoichiometric reaction between dissolved oxygen and the oxygen and the film-forming amine in the case of oxygen scavenger. So in case of, let's say, presence of the deaerator, the dissolved oxygen value will be to the level that the thermal deaerator can remove. So in case that the client has key performance indicator for dissolved oxygen, then we are also using in certain products an organic oxygen scavenger to deal with that level. So that is the only reason to have in certain formulations the presence of an organic oxygen scavenger. So we are again talking as the philosophy, most of the case, a single drum because it is composed of different actives and different functionalities. But at the same time, as Fineamin, we have also single drum of film-forming amine that we will discuss about. And also we have solutions that do not contain cyclohexylamine for certain reasons. And we also discuss it in coming slides. And happy to say that for our certain products, we have also NSF, G6 or G7 conformity. So this is also about the requirements in case that the people are asking for direct contact with the food, so on and so forth, that we can really supply it. So in the Fineamin treatments, specific cases, like in a fine tube boiler using of the Fineamin product, you can see the difference for a better protective film formation and passivation. So the top pictures that shows the client having an application of a traditional treatment and then without having any let's say, maintenance and shutdown period and cleaning and restarting again with Fineamin treatment. It has been just switched accordingly. And as you can see, in a course of 6 months only, there's a remarkable change. And the pictures are from the same, let's say, locations. You can see how the film form and protecting the surfaces. So this is a fire tube boiler. And for the application of direct food contact cases in the low pressure, again, you might be seeing it, the change of boiler water conditions as a course of even after the first week, but at the course of basically only 3 months, and how it has been changing. And it is something that has been expected because sometimes food industries, they are having issues of seasonal work, and then the steam load change, the operation of the boiler changes, and then there's an inconsistent level of the oxygen scavenger because of this change of, let's say, load and everything. So then the traditional treatment, unfortunately, have its own drawbacks and failures. While in Fineamin applications, they can easily have the film formed and kept intact all the time. So even for short periods of standby or changing it, there will be no change of Fineamin product dosage. And irrespective of dissolved oxygen concentration, we are not changing the application pattern. So hence, it is better controlling the situation. And this is also true for another canned food and beverage industry. So again, the problems were alike. This is entirely two different applications, two different continents, even I can say. But again, they were reusing it, local product, traditional approaches in that site, and then based on sulfite and phosphate technologies. And when it has been switched again at a course of few months, how it got improved in terms of the results. So that has been showing a better protection against oxygen corrosion. Also complying with the food direct contact of the steam. So when we are going to a higher pressure cases like 196 bar in a plant, as you can see, it is 1,020 tons per hour per unit with more than 10 units cases. So when the people, they are using traditional treatment based on hydrazine phosphate, so when it has been changed into the treatment with film-forming amine based of Fineamin products, there is an improved structure of the magnetite. So as expected, much lower blowdown values and better dispersion of even if there was a problem that is being remained in the system, like some scaling and some corrosion products, then through the application, basically those impurities started to be dispersed and removed through the blowdown. So stability and efficient treatment of the polyamines proven for such a conditions that we are talking as 196 bars and for the temperature as high as 540 degrees centigrade. So definitely it is easy to also show before making any inspection, because one of the core things is when we start using film-forming amine-based treatment of Fineamin versus the traditional one, in case there is any upsets, as I told you, like iron oxides deposited somewhere, and then the first thing is we will see the dispersion back. So this is, we call it online cleaning efficiency. So sometimes people, they said that, oh, we have seen a bit increased turbidity and increase the iron level. This is normal because of that dispersion, but through some period, then it start to basically stabilize, and then the color start to disappear. So, and then any iron value that is being measured before start to be decreased as well. And in this case, basically, again, a treatment that replaces the traditional hydrazine treatment, we are seeing the decrease of iron levels from 20 ppb part per billion to 10 ppb. So this is also the results people appreciated in the site. So the application of film-forming amines treatment of Fineamin is not just limited into the, let's say, high pressure cases, but also with the systems having steam turbines. So we are talking about better, thin, single layer, stabilized magnetite layer formation that will be again resulting in better heat transfer, and in case that there is a more than one layer of magnetite form that has been blocking the formation, so it will be lowering at the end also the energy costs. So it will be showing again online cleaning efficiency of deposits. Let me say it one time, like we are not talking about online cleaner, let's say, of the product nature, but it is because of, let's say, film-forming amines have dispersive capabilities like surfactants, so they have online cleaning efficiency. That is the issue. Now, speaking which of famous story of power plants having steam turbines. Let's make a further statements about the treatment concepts. So one of the most well-known treatment in steam turbines, steam turbine having power plants, is all volatile treatment. And we have basically two types. One is called all volatile reducing, having an oxygen scavenger and pH control, namely hydrazine or carbondazide and ammonia. And the other one is called all volatile oxidizing, solely dependent on the pH control. So there is the thermal deaerator efficiency is considered enough, and there is only the pH control. So as we are understanding from hydrazine or carbondazide or pH, basically there are no solids added to the feed water. So in that sense, we are not talking about, let's say, phosphate-related issues either. So because, in parentheses, there's also a second type of treatment for high-pressure cases using phosphate as, let's say, coordinated phosphate treatment programs. But in all volatile treatment, there is no usage of any type of phosphate. So then this is preferred in HRSG systems, systems with steam turbines, because there is a parameter called cationic conductivity or cation conductivity or acidic conductivity, and the turbine manufacturers are seeing it as an issue. So basically, although there are this so-called positive or pro points of all volatile treatment, we should also consider that there is no any buffering effect. So we are solely dependent on pH control and oxygen control. But in case that there is some upsets in the boiler feed water treatment plant, then there is no buffering, there is no, let's say, compensating effect coming from the treatment itself. So there should be a very much strict control of the feed water quality. Otherwise, all volatile treatment may fail. Then the famous parameter that the people say it, cationic or cation conductivity, known also the acid conductivity. What is it about? So it is basically non-specific measurement of anionic species like chloride, sulfate, nitrate, phosphate, etc. And basically in steam, such anions can generate issues on the turbine or turbine parts, blades or rotor discs. At the same time, as you can imagine, when they are being protonated, they will be forming strong acids. So they will be generating further corrosion issues. So this is why steam turbine manufacturers, unfortunately for chemical engineers, for us or water treatment companies, they are putting a very tight limit, and in fact, a very tough limit to keeping cation conductivity less than 0.3 microsiemens per centimeter. In parentheses, with film-forming amine treatment of Fineamin, we are not really more than 0.5. But again, this is more than that tough limit given by these turbine manufacturers. So, unfortunately, the curse is coming from the presence of neutralizing amines, because neutralizing amines, they also decompose into organic acids, and this will have the contribution to cationic conductivity. Although those organic impurities have not been conclusively linked to the corrosion damage in the steam turbine, there is no possible way to both have quantitative and qualitative result. So we are solely dependent on the quantitative result or quantitative limit, whatever given by the turbine manufacturer. Hence, we cannot proceed and use any neutralizing amine. So, as we said, ammonia and hydrazine, they don't have any contribution. So this is why all water treatment is one of the most preferred treatment understanding or philosophy for the steam turbine containing systems. So all the neutralizing amines, whether it is cyclohexylamine or morpholine or diethylamine-ethanol or monoethylamine, they have all contribution to the cationic conductivity. And basically, cyclohexylamine is one of the highest contributing amine in that sense. As you may be knowing, carbon dioxide have also that contribution, but it is considered like a noise, like a false contribution. So basically, if someone degasses the sample before measuring it, so the people can remove the effect coming from carbon dioxide. Now, these are the points about all water treatment, cationic conductivity, but at the end, the people should really, when the people are using all volatile treatment, must carefully balance the necessity of having a good pH, means boosting the pH, and the delicate equilibrium between the corrosion control, especially if there is or there are copper and copper alloys in the system. Because at the end, ammonia, hydrazine decomposition to ammonia will affect and will generate corrosion on steam turbines. So, speaking with cyclohexylamine, as we said, it is like other neutralizing amines, they contribute to cation conductivity. In addition to this technical point, there is another concern. And basically, frankly, this is a bit unproven. I'm sure that everybody agrees, and there should be more research and development and investigations to be done. But there are some health and safety concerns, like repeated long-term exposure may generate issues in kidneys, in livers, and maybe some issues about reproductive and fertility system in animals, so on and so forth. So we should also say the positive points of this cyclohexylamine, because it is widely used in many chemicals, being a solvent and an organic solvent, and also it is a chosen industry standard neutralizing amine in many formulations. So because it's high distribution ratio and high basicity, it is really a standard and industry standard chemical. In addition to that, despite that unproven concerns, it is still on the FDA approval list. That is 173.310, boiler water additives for the steam contacting directly the food, except dairy industry. So the bottom line, it is still FDA approved, and there is no global ban. However, in case that the people, they said that despite whatever it is unproven, but we don't want to use cyclohexylamine at all in our systems, then we are very happy to say that Fineamin manufactures a unique water-soluble film-forming amine chemical. So basically, that chemical has no any neutralizing amine inside, including cyclohexylamine. But of course, in order to have a complete treatment for the other concepts, then we have two main possibilities as a 2-gram solutions. The first one is that product, that application can be coupled with our another dram solution that contains other neutralizing amines, but no cyclo inside. So it will be a cyclo-free boiler treatment program. In addition into that, also, while we said that the steam turbine manufacturers, and because of the limit of cation conductivity, the power industry is mostly using all volatile treatment, but they would like to use and get benefit and performance of also film-forming amine corrosion protection. So it can be the second RAM for that treatment too. So this is the second possible options. And the third option would be, again, all-in-one single gram solution. And we are also working on it. Basically, it will have film-forming amine and other actives, but no cyclo in the drum. So, and it can be used as a single drum solution instead of 2-gram solutions. So the last part that we would like to say is also the possible automation for the Fineamin AT series produced by Fineamin. Basically, they contain a fluorescein molecule, means a traceable molecule that can be traced easily through the same pattern, as you may know, of monitoring and dosing the chemical automatically. So this is already present in our chemical portfolio. So in case that people are using it, of course, that you may ask how we will be detecting the fluorescent molecule. So it will be detected basically in boiler feed water, and it will be dosed in accordance with that. But this is a further automation and know-how from Fineamin company. So the analytical control, the measurement of the residual, traditionally can be done through titrometric way, as you see HALE test kit, as well as it can be done spectrophotometric way. Again, traditionally, it is Rose-Bengal method. So I would open a parenthesis into that. We make our own reagents for this, but at the same time, Dr. Lange developed also specific reagents in accordance with the Rose-Bengal. And then they made that measurement of the film-forming amine standard in their own spectrophotometer. And similarly, there is also another US company, Chemetrix. They also produces a different type of methods for the detection of film-forming amine. So basically, all the methods, they are been looking to measure the free residual, not something extracting from the film formed on the metal surface, but that has been something free that we are keeping in the system. So to wrap up, we are talking about a very reliable, sophisticated, easy, safe usage of a Fineamin film-forming amine treatment with different scopes, single drum or multi-drum solutions, but at the end, all organic, no contribution to TDS, no phosphate or sulfide or inorganic content, eliminating all possible things related into the dissolved oxygen levels or phosphate-related issues, so on and so forth, and beyond, non-toxic, environmental friendly, more than 90% biodegradable, and not having any hydrazine or carcinogenic active inside. So thank you for your kind attention. And now I will be stop sharing the screen, and we will be ready for your questions if you have any.
Thank you, Mustafa.
Sure.
if there are any questions. We will have another webinar on 15th where we will discuss some real world case studies with our colleague Wala Fargali. She has been working with our products for 10 years now, and she has a lot of experience. She works mostly for fertilizers industry, but also in medical field and others. So you have a question?
I have received a question. So the question is, can you give a brief information about the blowdown energy, water, and chemical usage gains of Fineamin products compared to conventional products? So this is a really, I would say, good question, but it is case by case because in every country, there are some different environmental laws and regulations, storage, handling, water costs, blowdown costs, energy costs, so on and so forth. But apparently, it is easy to see the savings. For example, uh, for a softened water-fed boilers, normally with traditional treatment, you cannot exceed cycles of 10, means 10% of blowdown. Even it will be even more because while someone designs the operation or the blowdown regime in the boiler, they will not be taking into consideration the contribution coming from the inorganic chemicals. So in our case, let's say in such a very, I would call exactly the same case, we may easily go to 20 cycles, means there will be 5% blowdown instead of 10, even 15. So you can easily then make based on, let's say, the cost of water and energy and chemical, so on and so forth in the designated country and application, differentiate between these 2 points. At the end of the day, we can say that Fineamin treatment will stay really, really competitive. Any other questions?
After July, we will be taking a break until September. And in September, we will continue with other technical sessions like boiling out. This will be a webinar held by our German partner, CVB. And we will also discuss some case study for the film forming. A case study that we've done in partnership with the German university. We are open to different subjects. If you have any proposal for future webinars, it's always welcome.
Exactly. So any other questions, please? Okay, so thank you very much for your time, and you may always. Oh, okay, there's another one. What type of dosing pump do you use for Fineamin? A good question. We haven't mentioned this, but not about the pump itself, but we should be saying it one important point. Sometimes the pump seals or diaphragm is made of a specific elastomer called Viton. And Viton is a brand produced by DuPont. So basically, film-forming amines in general, they do react with Viton. So in case that you are having a dosing pump with Viton before, let's say, starting the Fineamin treatment, you need to replace it with Teflon. Okay. There is also another question. What is the compatibility of the chemical traditional versus Fineamin if we would like to switch? It's also a good question. So basically, if you are using, for example, sulfide-based treatment, and you would like to switch to Fineamin treatment, you need to stop the sulfide and increase the blowdown until the sulfide becomes nil, zero. Then you can start it. So this will prevent a possible interaction between acidic and alkaline species. But other than this, with all the remaining, let's say, boiler treatment chemicals, basically, Fineamin treatment is actives compatible. In other words, if someone is still insisting to use phosphate, but they would like to also take the advantage of film-forming amine-based technology, yes, it is also possible that someone uses, let's say, theoretically, this is possible. Of course, I would say that it is not required at all, but if they would like to still keep phosphate and use film-forming amine or Fineamin, it is possible. Any other questions? So thank you and hope to see you for, okay, another one. Does the length of the condensate return pipes affect the chemical dosage rate or not? Well, this is an interesting question. Sometimes the condensate lines are extremely long. So normally we dose the chemical at a single point. I mean, that is if to the makeup water line or if there's a deaerator after the deaerator. But apparently, because of also the condensate or the steam, let's say content means only return if it becomes dirty and this and that, or in some way there is an air, I don't know, something that has been happening there, then we might be using an additional chemical to the steam lines directly, but it is not with film-forming amines. Normally, we don't have any problem, but if it is a specific process and the process is leaving some pH, let's say, decrease at a certain different condensate return lines, then it should be evaluated case by case. Any other question, please?
Thank you. Thank you, Pat.
Yeah. So as I was about to say, thank you to all of you. Basically, as you have now our contact information, our email. So feel free to send us any requests or questions. We will be delighted to help and reply your questions. And hoping that the film-forming amine-based treatment on Fineamin will give a better and safer, reliable protection and another depth of treatment compared to traditional treatment that the people think that maybe the traditional one was the only solution. No, and there are lots of options and lots of possibilities. We can always choose the best treatment chemical for your systems with the best service available. So,
If there is any other question, if not,
let me
I
see.
think
I think no. So, thank you and hope to see you during our next webinar. Have a safe, nice day or night, depending on your, let's say, time zone. And thank you.
thank you so much. Goodbye.